Hi class, how are you today? That figures. The learning target for today is to identify and name geometric figures. You're 3 if you can identify and name geometric figures. You're 2 if you can identify geometric figures but cannot name them. You're 1 if you can identify only a small amount of geometric figures. And 0, you cannot identify any geometric figures. Let's get started. Alright, so if you couldn't tell from the learning target, we're going to be doing a lot of vocab for this lesson. So I'm going to have a bunch of vocab terms and then define them and show examples on how to name them. So first we have a line. Definition of a line is an infinite one-dimensional figure. So one-dimensional means it only has 2 directions, left and right. So we have a line here, and we have points A and B on the line. And notice the arrows mean that it goes on forever. So it's infinite. And another way to draw it is without the points on it, and we have the L next to it. So it's another way to show it, and it'll be another way to name it. So to name this line, we have line AB. AB with a line over it with the arrows to show that it's a line. Or we can just have the cursive L there to call it line L. The definition of a line segment is a finite one-dimensional figure. So that's what you would normally call a line. But it has no end, or it has ends. It has endpoints. No, it doesn't go on forever. So an example of this is a line segment with endpoints A and B. And we name it by saying AB with a line segment over it. A ray is a one-dimensional figure that is infinite in only one direction. So it starts at an endpoint and then it goes on forever. To draw it, you start with an endpoint and then you have an arrow that goes to the end. So then to name it, you write AB and then a ray over it with the arrow. A point is a singular piece of data. It's just a point. So it's a point with name P. And to name it, it's P, just P. You don't have a point, it's just P. A plane is a two-dimensional surface. It can be infinite, but a lot of times a plane is also used to call something that's not infinite, such as a shape here with these points. Now I drew 2 planes here, one with points in it and then one with just a letter outside to name it. Now to name them, we have plane ABCD, all the letters in the plane, or the other one, just plane P. If it doesn't have any points in it, it's just the P. A polygon is an enclosed shape of at least 3 sides. So enclosed means it doesn't have any openings, it's completely cut off. An example, here I drew a pentagon, it's just a type of polygon with 5 letters, A, B, C, D, E. And to name it, you just name all the letters, A, B, C, D, E. Don't have to say, you can say polygon A, B, C, D, E, or even pentagon A, B, C, D, E, but all you need are just the letters. Do make sure you go in clockwise order, though, because if you have B, C, D, E, A, that's also fine. However, instead, if you say B, D, A, E, C, that's not in clockwise order, and that's not okay. It's got to be in clockwise order. So next we have a regular polygon, and I'm not sure why it's not showing up here, but when I edit it on YouTube, I should add an annotation that you can see. So the definition of that is a polygon with all equal sides and all equal angles. So if you see on this image here, I have a whole bunch of marks. These marks here are to show that all the sides are equal. And then the marks on the angles So all those sides are equal. A, B, C, D, E, F, they're all equal. Then on the angles, I have those marks as well. Those are showing that all the angles are equal. So angle A is congruent to angle B, is congruent to angle C, is congruent to angle D, E, F, and so on. So notice those angles there. Those are to show that they're all equal. And it may not look like they're equal in the picture, but that's just because I can't draw. Sorry about that. And to name it, you name it A, B, C, D, E, F. All the letters in it. Again, a regular polygon can have any number of sides more than 3, but in this case I just drew a hexagon, so this one has 6. But make sure to write all the sides. If you want to say regular polygon and then the letters, or regular hexagon and then the letters, that's also fine. A triangle is a 3-sided polygon. And triangle, and then with the letters A, B, C, and you name it with triangle A, B, C. We'll be dealing a lot with triangles. So with other polygons, you don't have to put the triangle symbol, but for triangle, you do. Just because it's very important. A circle is a shape where every point on the shape is equidistant from the center. So it's the same distance from the center. And so here I have a circle with a center C, and you name it circle with center C. So the circle with this little dot in the middle to show that it has a center, and then the C to show what the center's name is. Parallel lines. So now we're going to deal with some terms that don't necessarily need names. So parallel lines are 2 lines that never intersect. In an example here, we have 2 lines, and these little red arrows I've put here are to mark that they're parallel. That's how we know they're parallel, is that they are marked. Notice I've been doing these marks. Never believe that something is what it looks like unless it's marked. So if those lines didn't have those parallel line arrows, you wouldn't assume that they're parallel. Perpendicular lines, 2 lines that intersect at a right angle. So notice here I've got that little box there. That's to show that it's a right angle. So 2 lines, they intersect specifically at a 90-degree angle. A segment bisector is a line that cuts a segment into 2 equal segments. So we have that line cutting that segment into 2 equal parts. So the left side is congruent to the right side. They are equal. And these marks here show that those 2 sides are equal. That's how we mark to show that they're equal, by just putting those little dashes there. An angle bisector is a line that cuts an angle into 2 equal angles. So we have an angle here, and a line that cuts that angle in half into 2 equal parts. And notice those little red marks there. Those show that that angle and that angle are equal. Those 2 angles are equal. Now we're going to talk about angles. So you may have noticed I didn't do a definition of this one because this is very special and very important. So an angle is the space between 2 intersecting lines. So types of angles, we have acute angles, which are less than 90 degrees, obtuse angles, which are greater than 90 degrees, right angles, which are equal to 90 degrees, and straight angles, which are equal to 180 degrees. Naming angles. So we have an angle here. We have an angle number, which is 1, and then we have letters A, B, and C. So you name it, you can name it using the number, or you can name it using the letters A, B, and C. So a few different ways you can name it. One way, the easiest way, is angle 1. You've got a number there, you call it angle 1. Or you can name it by the vertex, which in this case is B. So you can name it angle B. Or you can name it by all three letters. A lot of times you'll need all three letters, so A, B, C. So it goes A, B, C, so you say angle A, B, C. Or you can go backwards and instead go C, B, A. So it's angle C, B, A. The B has to be in the middle though because it's the vertex. So since B is the vertex, B's got to be in the middle. So if you said BCA, that would be wrong, or ACB, because you instead would say C was the middle. But no, B is the middle. B is the vertex, and that's what it needs to be. So the vertex is always in the middle. Now with this one, we have multiple angles in here. We actually have 3 angles. We have the 2 small ones, and then the big one that the 2 small ones make up. With this one, you can name it with the numbers. So this first one we'll name angle 1, so angle 1 is a possibility. We can't name it by the vertex though, because the vertex has multiple angles connected. So you can only name it from the vertex if there's only one angle there. But there's multiple, so that's an issue. So we can't name it angle B. But we can name it by all 3 letters. A, B, D. Again, with the vertex B in the middle. So angle A, B, D. Or again, we can go backwards, angle D, B, A. Now, let's name angle 2. So, angle 2 is a possibility. Or, we can name it with the letters CBD. So, angle CBD. Or backwards, DBC. Again, with B being in the middle. Now what about the big angle? How would we name that one? How would we talk about that? So the big angle, which is a combination of angle 1 and angle 2, we can't say angle 1 plus angle 2. That's not necessarily one angle. So we have to use all 3 letters. A, B, C. So we say angle A, B, C. Or again, we can go backwards, angle C, B, A. Now we're going to talk about angle combinations. And again, something messed up, so I'll throw it on the YouTube annotations. But with angle combinations, first one is adjacent angles. So here I'm talking about adjacent angles. So with adjacent angles, they are angles that share a vertex, which is B in this case, and a side, which in this case is BD. So they share a vertex and a side. Complementary angles are 2 angles that add to 90 degrees. So here we have angle EFH and angle GFH. Those together add to 90 degrees. So they are complementary angles. So we'd say the measure of angle EFH plus the measure of angle GFH equals 90 degrees. Supplementary angles are 2 angles that add to 180 degrees. So here we have angle IJL and angle KJL. Those 2 angles together make a straight line. A straight line is 180 degrees. So those two angles add to 180 degrees, so they are supplementary angles. So we say the measure of angle IJL plus the measure of angle KJL equals 180 degrees. So next we're going to talk about types of triangles. We have acute, obtuse, and right triangles. Now, I know you know what acute angles are, obtuse angles are, and right angles are, but now we're going to talk about acute triangles, obtuse triangles, and right triangles. First of all, I want to say, ignore my drawings. I'm not a very good artist. Second of all, an acute triangle is one where all the angles of the triangle are acute angles. So, all angles are less than 90 degrees. An obtuse triangle is one that has exactly one obtuse angle. So, one angle is greater than 90 degrees. A right triangle has exactly one right angle. So one angle is equal to 90 degrees. So the next three types of triangles we're going to talk about are equilateral triangles, isosceles triangles, and scalene triangles. So an equilateral triangle is a triangle that has all equal sides. So notice that I put marks here, here, and here. That's to mark that each of these sides are equal to each other. So remember when you see marks like these, it's saying that this line is the same as this line is the same as this line. So an equilateral triangle has all sides are equal or congruent. Isosceles triangle, only two of the sides are congruent. So this one and this one are congruent, but this one is not. So for an isosceles triangle, two sides are congruent. In a scalene triangle, notice I didn't put any marks on it. This side, and this side are all different. So a scalene triangle is no sides are congruent. Alright, so that's it for the notes. Now we have the sponge activity. For these 4 problems, you're going to attempt them all, and if you attempt them, you get full credit on the homework, and if you get all of them right, you get a bonus point on the next test. So for this, they want you to identify and name each geometric figure. So what that means is, first, what kind of figure is it? Is it a line? Is it an angle? Is it a circle? What is it? And then name the geometric figure. So back when I showed you how to name them, name it like that. That's it for the video. Remember, take notes on the entire video and attempt the sponge activity. When you're done, submit them to Google Classroom. Have a good night.